So, in explaining this CO2, so in task 1, observation 1.1, falling barometric pressure or the approach of low pressure air is often an indicator of rain and ice and snow arriving soon. So a barometer that is falling indicates that a pressure system is moving in and you can expect poorer weather. So you can expect poorer weather if your barometric is falling and cause a low pressure system. So in observation 1.2, when the air is dry and cold and pleasant, the barometer reading rises, and a rising barometer means improving weather, which is when an atmospheric pressure drops suddenly. This usually indicates that a storm is on his way. So when the atmospheric pressures drop suddenly, this usually indicates that a storm is coming. So that is our task 1, 1.1 and 1.2. So in our task 2, knowing our sea condition. So this is knowing our sea condition. So in 2.1, according to the table, 7 knots to 10 knots wind speed is gentle waves begin to break, lives in constant motion. So our sea condition is moderate. So our sea condition in 7 to 10 knots wind speed is our sea condition is moderate. So 2.2, according to table, 17 to 21 knots, and probable wave height is 1.2 meter to 2.4 meter. Is our weather condition. So our weather condition is fresh according to Bureau weather terms. So fresh so the weather condition is fresh according to Bureau weather terms. And our sea condition is rough. So our sea condition in 17 to 21 knots wind speed is rough. So in 2.3, according to the table, 34 to 40 knots are probable height. Wave 1, according to 34 to 40 knots is stormy wind, which is that a small branch is broken. So our weather bureau terms is stormy wind. So in our sea condition, which is very rough. So in 2.4, according to the table, 11 to 16 knots, our weather is moderate, which is numerous, which caps dust and leaves blow. So our sea condition is rough. So in 2.5, in task 2, according to the table, 48 to 55 knots, it is a whole gale with our sea condition is very high. So that is our sea condition in task 2. So in task 3, southern hemisphere and northern hemisphere. So the southern hemisphere, winds blow around a high pressure in an anti-clockwise direction and around a low pressure in a clockwise direction. Generally, prevailing winds blow east to west rather than north to south. The Coriolis effect makes wind system twist counterclockwise in the northern hemisphere and clockwise in southern hemisphere. So that is our explanation in our CO2 assessment,